Hey folks, I'm really happy to speak at Django US 2024. I'm going to talk a little bit about Django and Celery and their amazing love story, right? My name is Hugo. I'm a partner at Vinta Software, where I've been working for the past 7 years. Some of you folks might have already crossed with Vinta before by using one of our open source packages for Django, like Django React boilerplate, Django work permissions, DRF read and write serializers, Django virtual models, and the newest one, which is really fresh, which is Django AI Assistant. You should really have a look. Uh, we are a company that really cares about the open source world and especially the Python community. We contribute in with a lot of open source software, and also we've been present in most conferences all over the world. So that's something we really love, and we've been there for a while already. So about myself. I've been working with Django for the past 10 years in very different kinds of projects, most of them using Celery. And that's what we're going to talk about today. So, to start this talk, I'd like to talk a little bit about Django. Django is almost 20 years old, and its philosophy has made many projects very successful so far. What I really love about Django is it has batteries included. Uh, there is kind of the right way of doing things like authentication, authorization, interacting with data, security, things like that. Django is full of good opinions on all these topics. So and that basically allows us to work together and make a whole ecosystem in an integrated way, built on top of Django, like using the same base. Uh, and that's because of that we have tons of packages that are really useful. We have events, we have meetups, we have, and especially there is an active development in the main framework, which introduces exciting new features on every new version. Uh, but there's a known problem of Django that couldn't still be fixed. Uh, and that's like Django performance, right? Django uses Python, which is not known for being a fast language, like compared to Rust or C or Go. Uh, and on top of that, Django wasn't built to work with multi-thread. Its asynchronous features are still being developed actively. They are still maturing. Uh, the ORM itself can be misleading sometimes with regard to performance, uh, but there are workarounds to make Django a bit faster. Uh, in the database side, you can avoid n plus ones, for instance, like being more cautious on the way you write queries. You can use caching. You can make smart database indexes. You can use data normalization. You can run operations in the background, right? All these techniques could make your application run smoothly and serve a ton of users simultaneously. That has already been done in the past, right, by big companies. Uh, but I want to talk a little bit more about the last one, running operations in the background. Uh, Before that, let's have a look on how Django works in the background, right? Uh, Basically, Django exposes a WSGI interface or web server gateway interface. That's what a server like Unicorn or Whiskey uses to run a Django process, right? They kind of connect to that WSGI file in your Django project. Uh, these servers themselves have a request load balancer. Basically, this part of the server receives a lot of requests, and they map these requests to processes they have, right? So each Django process has like the whole Django environment loaded there, in memory. And each of these processes picks a request at a time, and only gets the next one when the previous has finished being processed, right? So long running requests are kind of expensive, right? Each Django process loads the whole framework core, right? So it also it's expensive to have too many processes, right? Because all of them have like a cost to be loaded, right? Uh, and requests hold a Django process each while being processed. So there's no way to run multiple requests at the same in the same process, right? There's no multi-thread in Django processes usually, right? There might be workarounds, but we're focused on the main thing today. Uh, why why running operations in background, right? Requests should be processed quickly, so we don't have to roll the process for too long. We want to be able to process the next request as quick as possible. Otherwise the queue is going to be too long. uh, and we also want to give feedback to the user as quick as possible as well, so we can retain their attention, right? Attention is a very valuable in these days, so we don't want like the user to switch tab while they wait for an operation he started on our app, right? We want to keep him in our tab and like maintain retain his attention, their attention in our platform, right? uh, and Celery, it's a tool that can help with that, right? Celery is an asynchronous task queue or job queue, which is based on a distributed message passing, right? So it's what the most important word here is distributed, right? It separates a syntax execution from your main application. So it doesn't run in the same process that Django runs. It's a completely separate process that uh, just worries about these as asynchronous tasks. Uh, it is also very fast, and it's very well integrated with many tools, right, including Django, right? So with Celery, you can have access to your models, to your services, your functions, your classes, and all that jazz, right? And Celery loves Django, right? Celery basically has dedicated documentation for integrating with Django. It actually there are ways to configure Celery using Django settings with no extra boilerplate. Uh, Django is it's allowed to be accessed within tasks, so you have full access to your ORM and your managers and your query sets and your services, classes, etc. And there's also an important community around Celery and Django, building packages that like enhance these integrations. That uses Django database for managing some of Celery things and things like that. So there's a whole ecosystem that helps us integrate them both, right? And here's how it looks like to integrate Django and Celery. This is like very basic use case, so I'm just showing you how it can be done, how quick you can integrate them. Basically, here I'm writing this process order view, right? It receives a request, it creates an order object based on the user, and it calculates, it kind of call the calculate user score task. So suppose you have like the this function called calculate user score that is very slow, but it isn't that important that you run it immediately after you create an order. It can have some eventual lack of synchrony, and so that's the perfect use case for us to move this task, move this function to another process, right? To running in background, because it's just going to bloat the request, right? So in here, we are moving it to a task function that receives the user ID, it picks the user from the database, and it actually calculates the user score. But before all that happened, we actually give a response to the user. So this delay method here, it's just going to add the task to the queue. It's not going to execute it immediately, right? It's going to be executed in the background. So this is kind of a hello world for Celery, right? And what this can give us, basically, what async tasks can be used for. You can delegate long-lasting jobs like the one that we've just seen. Uh, we can execute remote API calls. Like APIs can fail, right? So we can use like Celery to run to like kind of wrap these API calls and give like have retries running without blocking the request, right? We can also prepare and cache values, right, to make queries a bit lighter, right? We could spread book database insertions over time, for instance, like to avoid overloading our database. We can execute recurring jobs, things like that, right? There's many use cases for async tasks, right? And how does it work with Celery? Basically, Django uses a Celery client that gives kind of that delay function, for instance. Uh, and it basically queues a message to the broker. A broker could be many platforms, right? Many kind of queue managers, right? It could be like RabbitMQ, SQS. It could be Redis itself, right? So we can use multiple queue manager as a broker, uh, but like we choose one, and like whenever we call this client, Django is going to send a message to this broker and put it on the queue. And Celery is going to be watching this queue, and it will mark a task as started. It kind of depends on your settings there. It may or may not mark as started. It may just start it, but and it marks it as succeeded after it finishes processing it. So the second part is like after Celery finishes uh, the processing of that message of that task, it will also deliver the result of that task to a kind of database. We call it results backend, and it's basically storing task results. So you can query these results with other tasks or even with Django. You may want to wait for a task to run to get its result. In the case that we showed, it may not make a lot of sense, but there are use cases for that. If you're just sending an email with Celery, for instance, you might not even want to wait for the result. So the result backend will kind of be useless in that situation, but there are situations where it can be used, right? So when you configure Celery, you actually have to give it a results backend so it can store the results there. It's just a database, a normal database. Uh, so, but like it's it's a good love story, right? Django and Celery, but it's not always rainbows and butterflies. We can say it's a tough love, right? There are many things that can go wrong. Whenever you're introducing a distributed system into your application, it makes things a lot more complex, right? Like all connections may fail. There are a bunch of connections now. You have Django to the broker, the broker to Celery, the Celery to the results backend, the results backend to Django. So there are many connections that may fail, right? You also have a lot of concurrency being added there, adding a lot of complexity. So we can have like tests that never finish, outdated data, issues that only happen in production. It's kind of introduces a lot of noise, right? Let's say Celery has a strong personality, right? Celery is a distributed system, which means there are many points of failure, right? And here we are going to focus on these four problems that I've been through in the past in my whole experience with Celery. These things always have caught me in the past, and I have to handle it correctly. The first one is outdated data, right? Sending complex data as parameters to Celery may result in unexpected stuff, right? In this example I'm giving here, we are passing the user model to a Celery task, right? And we are basically calculating the score here and saving the user. And why this is kind of tricky, why it might not work as expected? Because the user model may change between the Celery task being scheduled and it actually being executed. And as we are passing a model object, the model may be outdated. I can even have deleted that user if let's suppose the task queue is full, right? It has a lot of tasks to be executed there. The user may have been deleted, and whenever you run this, the user may not exist anymore, right? So you calculate the score of an unexistent user, right? In this other case here, the right way to do this is basically passing a reference instead, right? I'm passing the ID of the user. I'm getting the user by the ID. If the user doesn't exist, I just don't run the task anymore, right? But if I can find the user, I'll get the up-to-date object, right? And I will calculate the user score accordingly. So this is the first thing. You have to be very careful to what you pass to Celery tasks as parameters, right? Usually you should rely on references, not on like complex objects, right? Serialization is necessary. Uh, it under the hood by default it uses pickle, which can actually pass like complex objects through, but that's far away from ideal. You shouldn't rely on like passing complex objects. You should like pass references and remount that these objects on the task itself. Okay. Uh, the next problem is duplicate runs, right? Depending on your Celery setup and task configuration, it may not be guaranteed that your tasks are only going to run once, right? Multiple workers may pick the same task at the same time, for instance, right? You have multiple workers looking at the same queue. Both of them can get the same task at the same time. And this could happen depending on your configuration. Uh, a task may be interrupted and requeued, for instance, right? If like a worker fails and the machine restarts, uh, you may have like a task that was interrupted and was requeued and will be executed again. So you have to ensure that your tasks are atomic and idempotent, right? In this case that I'm showing here, this example, we're storing a reference to the latest order we processed in the user model, right? You can see in the line 25, whenever we update the user score on the line 24, after it, we just store the latest order ID and we save the user, right? We save the user. That means if we call this task again with the same user and no new order, we're just going to pick again this last order ID, right? And we are going to exclude that user with a reference to that order ID. So if there is a new order, we are going to recalculate. But if the order is the same as the last one, we are not going to do anything. We are going to just return early, like in line 22, right? We are not going to be able to pick the user, and we are going to return early. So this function, it also has this transaction atomic decorator. So if something fails here, or if this function stops in the middle, it will just roll back everything, right? Roll everything back, and will not leave any like data updated, not completely, right? So the other problem we can see in Celery projects is a little bit more complexity on error feedback, right? Because whenever you pass the baton on to a Celery worker, if it fails there, you may not be waiting anymore in Django. So you may not be able to return an error result to your user. So user may receive a success message from the request, but the home operation may still fail, right? So whenever we are developing a flow that like relies on sync stuff and async stuff, we need to take this possibility into consideration and give like uh, a feedback, not like a success feedback immediately to the user, but a feedback saying that this is still being processed, and do some sort of polling to check if this was completely successful or not. You may also need to be able to undo operations if it has partially happened synchronously, and the other part is happening asynchronous in background. You may need to undo this first part that happened synchronously. So uh, it adds a lot of complexity for error feedback and error handling in general. You need to take that into consideration when developing uh, features that will touch both sync and async at the same time, right? And especially if it involves user feedback. Okay. Uh, so there's this fourth problem, which is conflicting operations. Right? So while a task haven't still run, another operation is triggered by the user, for instance, right? This operation conflicts with the one that's still pending, and creates like a state that it's not predicted, right? It's not predictable. So uh, for instance, let's consider these use cases. Uh, User can add nodes to our system, right? User can also delete a node, and user can bulk create copies of a node. So you can choose a node and create a bunch of nodes based on that existing node, right? So let's look at this following flow I have on the right. Uh, so let's suppose the user starts creating a new node. It creates, then triggers the creation of 10 copies of the node. This will run in background because creating 10 copies may be a little bit longer. We don't want the user to be waiting on that. Uh, so it happens in the background. This task is kind of queued. It goes through queue, and it will be executed by a Celery worker. Uh, then the user deletes the original node before the task to copy the 10 nodes run, right? The task runs, but the original node isn't available anymore, so it cannot be copied, right? You cannot like copy something that don't even exist anymore in the database, right? There are many solutions to this. Like you can implement, for instance, soft delete on the node. So whenever you delete the node, you don't actually delete it from the database. You just mark it as deleted, but you can still find it on the database, and you're still able to create these copies. Uh, you can also cancel all pending tasks before deleting. So whenever I try to delete some node, I'll query for pending tasks around that node that will do something to that node, and cancel all of them, all the pending ones. And after that, we like other alternative is just locking nodes with pending operations. So whenever we want to do something uh, on an existing node, we before creating the task, we are going to mark this node as like locked. And whenever we try to delete the locked node, we'll get an error, for instance, because it's still locked. So you have to wait for it to be unlocked before you can do other operations with it. So these are alternatives for these conflicting operations. This is just an example. This can be a lot more complex depending on your use case. But like async may create a lot of issues. You cannot have this just do a rollback, a database rollback. You don't have like atomic operations, so it's hard to have like atomicity between the sync part and the async part. So basically, you have to handle it by storing state or even canceling pending stuff, right? Now let's talk a little bit about how to make things a little bit smoother with Celery and Django. There are ways to work around some of these issues that we talked about, right? There are some tips that can help, like we're calling couples therapy here. So some tips to help the relationship to flow between Django and Celery. Uh, so if you're going to retry tasks, for instance, you need to use exponential backoffs, right? You don't want to like give a fixed number of seconds or milliseconds between the retries, because, for instance, if you are making a request to an API, this API probably won't be back if it fails. The request fails. It probably won't be back within a fixed number of seconds or milliseconds, right? You probably want to wait a bit more between the latest calls, right? So it's important to keep your backoffs exponential between retries, right? Also, tasks shouldn't raise exceptions the same way like views don't are not allowed to raise exceptions, right? If you run an exception in a Django view, it will raise a 500 error, and the user won't know what happened, right? So the same thing applies to Celery. If you raise an exception, it will just fail in a terrible way, right? In an uncontrolled way. So ideally, you should handle all exceptions. And if there is nothing to be done in the code for like adjusting the state because of that exception, you can just like send a report through email or through a monitoring tool, something like that, right? So exceptions should not be unhandled in Celery tasks the same way they should not be unhandled in Django views, right? Monitoring is also essential, right? Like Celery adds a lot of complexity. You need to kind of be able to see this complexity, see how it's going. So there's Celery Flower. This is a package that can help, right? It can help you see the current state of your Celery setup, right? You can see the running tasks. You can see the tasks that have already run. So it can help a little bit for you to understand what's going on. There's also this flag called all is eager. You can do it by task, or you can do it globally for all Celery tasks. And this is very useful for development, right? Whenever this flag is active, the tasks kind of run synchronously. So whenever you call a task, it will run immediately instead of running in another process, right? It will just run, which makes debugging a lot easier, right? If you don't want, if you are actually wanting to use the remote thing, having a different process for Celery, RDB could be your best friend, right? RDB is basically a remote debugger. So whenever you set up a breakpoint, it will stop the execution there and it will open a connection. So you can have a terminal connected to it with Telnet, and you can actually send like debug signals. You can check like variables values. You can like send a next signal or a continuous signal, things like that. You can debug the whole thing, even with remote workers that are not in the same process as your Django application, right? So RDB could be very helpful. It's kind of a built-in thing, so you can import it from Celery library, right? It's available within Celery. You don't have to install anything external, so it could be like a really good friend for you. It could really help. The second part of the couples therapy, I would like to mention a good tip for long tasks, right? Long tasks may not work exactly as expected with Celery, right? Because like imagine that you are the manager of this task. Like you cannot know if the task has, for instance, frozen, right? It may have frozen. It will not give any result ever. It's just like locked in there. So in that case, you probably want to have a timeout, right? So this is configurable, but you probably don't want tasks to run that long, like hours. You don't want that. So in that scenario, you probably want to split the task into smaller ones. to make sure that you have like a sense of progress, right? And you can know the things are running and there's no timeout like killing your task while they're still running, right? Another thing about Celery is that monitoring tools are very limited. I talked before about uh, Celery Flower, right? Or Flower. I don't know how you pronounce it. I think it's Flower. Celery Flower by Flow, right? So uh, you may need to implement some monitoring yourself. Like, for instance, I had in the past to implement like queues, heartbeats, right? To know if my queues are well balanced. I have multiple queues for different sorts of tasks, right? And some queues were like being very full, and other queues were being very empty. So if a queue is full, having a heartbeat may be helpful because if you schedule a new task, it may take like too long for it to run. So this is something you might have to implement yourself. I had to implement myself in the past, right? But like there are some paid monitoring tools that might also help in there, right? Like things like New Relic or Datadog may help a lot in monitoring your Celery tasks and having useful logs and understanding the state and all that jazz, right? Uh, Another thing is that Celery is an excellent tool for asynchronous tasks and for doing simple jobs, but like for complex workflows, it might not be very reliable, right? It may be, it has a lot of open issues and many complaints of lost tasks and unpredictable behaviors when you're running very complex stuff. So it may not be the best tool for that. But don't worry, like the Celery and Django's relationship is non-monogamous. Like these tools, other tools can live together with Celery, right? For instance, you could use Celery for doing simple stuff because it has like very little boilerplate. It's very easy to use. It's the learning curve is very little. But you could use like temporal IO to run like more complex stuff. It has like a more robust infrastructure. It's kind of like created to run these complex workflows. So even include like better monitoring tools like built-in that you can rerun tests and do stuff like that. So for very complex stuff, you may want to look into other tools for that, right? But if you're dealing with simple stuff that needs to run async, uh, Celery could be your best friend, right? Other than that, we also have this dev checklist site. Vinta has put that up, but it's an open source project as well. It has a bunch of dev checklists, and there's one specifically about Celery. Like my coworker Felipe Ximenez has put this up, and it has a lot of best practices you should follow when writing integrating Django with Celery. So basically, you should have a look at that. It can be very useful if you're starting a new application or if you're configuring a new integration, right? And that's it, folks. Thank you for hearing me. Hope you enjoyed the presentation, and I'll probably be on the event channel if you wanted to talk about Celery or Django or anything related. I'll probably be there. If you want to talk, just ping me. Okay. This is my email if you want to talk about it as well. And that's it. Thank you.